applications of normal, negative binomial and multinomial distribution. First 6 questions are coming from normal distribution. 7, 8, 9 and 10. 9, 7, 8, 9. These are the questions from negative binomial. And today we are going to study applications of multinomial distribution. That will be end of your practical. Let us try to read the question and see what the question says. A quality control supervisor inspects the lot. The lot is nothing but production. The previous experience shows that 10% items are rejectable. From where? From the lot which is under inspection. 80% items are acceptable and 10% items are acceptable after rework. So this is the past experience about the production process in a certain company. Suppose a lot of 15 items is submitted for inspection. The question asks, find the probability that 2 items are rejectable, 8 are acceptable, and 5 needs to be reworked. Is the first bit. Second bit, find the average number of items rejected. Also obtain its standard deviation. Now the question is coming from multinomial distribution. What is a multinomial distribution? It is an extension of binomial what you studied in your first year, first term. Multinomial, we define more than 2 variables and then we study the probability distribution of these variables. Basically, if you study any one random variable from multinomial, the particular random variable is a binomial that I taught in your theory class. Now, let us see how to solve this question. Does anybody is there waiting to join? No. Okay. So now I will proceed ahead. This is your question number 10. I define 3 random variables according to question. X1 stand for number of items are rejectable in the given sample. X2 number of items are acceptable in the given sample. X3 number of items are acceptable after rework in given sample. Now these 3 variables are defined on what basis? They are defined as per questions information. The lot which is provided to you for inspection has three type of characteristics. The item in the lot may be rejectable, the item may be acceptable, and third is items are acceptable not as it is by doing some rework. So every item has three possibilities. That item may be rejectable, may be acceptable, may be acceptable after rework. So for every item, if there is two possibilities, then you go for binomial. And if there is more than two possibilities, we use multinomial distribution. So according to this information, how कल आएंगे जी हाँ बैग रखे बाहर वो मेरा है मैंने उनके पास पैसे दे चुका है उन्होंने वो 3 बजे चले गए जी So this problem has three outcomes for every item, and that is why it is a case of multinomial distribution. So we define three variables according to three characteristics of every item. So I say x1, x2, x3 follows multinomial distribution with parameters small n, comma p1, p2, p3. What is n? N is number of item under study. Here, how many item in the sample? That is small n. Question says 15 items are under inspection. So small n is 15. What is P1, P2, P3? These are the probabilities having such type of characteristics to the item. Rejectable, how much probability? Acceptable with how much probability? And acceptable with rework, how much probability? Question says 80% items are acceptable, 10% are rejectable, and 10% acceptable by rework. So P1 chance of rejecting the item, including observation in first class, first group, that means group which is a rejectable, that is 10%, so 0.1, 10 upon 100. P2, probability of including observation in the second group. What is the second group? Group of acceptance. That is given to be 80%, so 0.8. P3, probability of including observation in third class, that means item which is accepted by doing some rework, 10%, so 0.1. B, remember, under multinomial, sum of probability all should be 1, and sum of values taken by the variable should be equal to small n. That is the characteristics of multinomial distribution. Here P1 0.1, P2 0.8, P3 0.1, so total become 1. We want to find the bit number 1, probability 2 items are rejected 8 are accepted, and 5 needs to be reworked. So x1 taking value 2, comma, x2 taking value 8, comma, x3 taking value 5. Now you know the formula of multinomial distribution. Probability x1 comma x2 comma dash 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 xk equal factorial n. We remember there is a factorial line. Divide by x1 factorial multiply x2 factorial dash dash xk factorial. P1 raised to x1, P2 raised to x2 dash dash pk raised to xk. So what is this? This is your multinomial distribution with conditions on the quantity. Individual variable xi taking value from 0 to n. There are k variables. That's why it is multinomial. Sum of the k variable equal to sample size. Total of probability should be 1. These are the conditions which are imposed on variable and probabilities. Now question become very simple. Probability of x1 is 2, x2 is 8, x3 is 5. 2 plus 8 plus 5 is 15. The condition number 2 is satisfied. 15 factorial divided by factorial 2, factorial 8, factorial 5. First probability raised to x1 is 2, second probability raised to x2, 8, third probability raised to x3, that is 5. By scientific calculator, you simplify this, answer is this much. Bit number 2, average number of items rejected. Now this rejection is for your x1 and average means mean. So mean of x1, I told just now, every random variable, particular random variable is a binomial in case of multinomial distribution. So question asked about average number, that means expectation of what? Rejectable items. And what is the random variable for rejectable? The random variable is nothing but x1. So getting average number of rejectable is expected value of x1, and that is n multiply p1. You know binomial result. N is 15, p is 0.1, answer is 1.5. At the same time, they are also asking standard deviation. Standard deviation is a root of variance of variable under study. N multiply P1 multiply Q1. If I forget the root, it is nothing but variance of binomial for random variable x1. Taking the root, get standard deviation. Root 15 multiply 0.1, Q is 1 minus P, that is 0.9. Simplify, that is the answer. So this is the solution, this is the application of multinomial distribution. Let us try to read question 11 and then we'll solve. A regular die is rolled 12 times. Find the probability that each face will appear twice. Now, why it is a question of multinomial? It is a question of multinomial because the experiment what you are performing is a throwing of a die, throwing of a dice. And you know every throw has more than two outcomes. If your experiment has exactly two outcomes, you apply binomial. And if every trial has more than two possibilities, then use multinomial. Just like in question number 10, in every product, every item classified in three categories: rejectable, acceptable, acceptable with rework. That's why it is multinomial. Similarly, in question 11, you are performing experiment throwing a die. And you know, throwing a die has six possible outcomes. And that is why it is a question of multinomial. What is asked? They ask to decide the chance that each face will appear twice. See the answer of the question. How many variables I will define? I will define totally six variables. Xi equal number of times ith face occur in a given experiment. So X vector in statistics, this bar is not a sign of vector. You have to write bar in the denominator. If you write in the numerator, it become a mean. So don't make confusion writing a bar on the head. Usually in mathematics, if you want to indicate vector, you put a bar on the head. But in statistics, if you put a bar on the head, the meaning is mean of that variable. So to overcome this practical difficulty, statistics peoples write bar in the bottom. So X vector follows multinomial distribution. Now when I say X vector, for this experiment, how many possible outcomes? That is a 6. So X vector, that means x1 comma x2 comma x3 dash dash x6, follows multinomial distribution n comma p vector. So there will be p1, p2, p3, p4, p5, p6. What is pi? Pi is a probability of occurring ith phase in the experiment. Suppose you are throwing a fair dice, unbiased dice. So every outcome is with equal probability. That's why P1 equal to P2 equal to P3 equal to P4 equal to P5 equal to P6, and that is equal to 1 by 6. N equal to sample size. How much sample size? 12. From where this 12 comes? Question says you throwing a die 12 times. You are rolling a die 12 times. That's why this 12 is nothing but your n, small n. We want probability each face will appear twice. What is the meaning? The meaning is probability x1 taking value 2. That means if you perform the experiment, throwing of a dice, another dice, this is your dice, suppose uh, so you have dice like this. So what is coming on the upper face? This is your dice. So here I will make a record. This is upper face. So I want two dots. X1 2, X2 2, X6 2 appear twice. Each face will appear twice. That means one dot coming two times, two dot coming two times, six dot coming two times. This is the formula of multinomial distribution with six variables. Now replace this. That is the answer. N is total repetition, total dies, that is 12 factorial. X1 2, X2 2, X3 2, and so on, 2 factorial, 2 factorial, 2 factorial. Each plot is equal 1 by 6 raised to 2, 1 by 6 raised to 2, and so on. By scientific calculator, you get the answer 0.003438. Now we study the last question of this practical. 6 independent observations are taken from a continuous random variable x having PDF. This is your PDF. Fx equal to 2x, x is between 0 to 1. Fx equal to 0, otherwise. What question says? From this PDF, we made 6 observations. That means from the interval 0 to 1, we draw 6 values. What is the condition? Suppose the range of x is divided into 4 equal parts. This is the range of interval of random variable. I divide this range in 4 equal parts. Find the probability that exactly 3 observations will be from the leftmost part, 2 from the next part, 1 from the third part, and no observation from the rightmost part. So I divide my random variable x in 4 and then I draw 6 observations. So I have a probability the observations which I draw has some chance to come from the first part, second part, third part, and fourth part. And that's why question become a multinomial distribution. Question number 12. X1, number of observations belong to first part. What is first part? Interval is 0 to 1. Divide in 4 part, 4 equal part. So I say 0 to 0.25, part 1. 0.25 to 0.5, part 2. 0.5 to 0.75, part 3. 0.75 to 1, it is the last part of the range 0 to 1. I divide 4 random variables because I divide the range of random variable in 4 parts. X vector follows multinomial distribution with n comma p vector. N equal to 6 because I am making 6 observations from given PDF. P vector is a probabilities P1, P2, P3, P4. How to get these probabilities? P1, chance observations belong to the ith part. So for P1, it is the first part. What is the first part? 0 to 2.5. 2x, it is the function under study into dx. Simple integration. This gives a probability that observation belong to the first part. Calculation, simplify, answer coming this much. Get it? P2, second part, observation belong to second part, 0.25 to 0.50. Repeat the calculation. P3, third part, 0.5 to 0.75. Solve the integration. You get this answer. P4, 0.75 to 1. 0.4375. The total of this 4, P1, P2, P1, P2, P3, if you make a total should be 1 as per the condition of multinomial. What is next step? What is happening? What is the next step? Next step is, after getting the probabilities, the total of P1 plus P2 plus P3 plus P4 should be 1. You can check it. We want probability exactly 3 observations belong to the left, that is first part, 2 from the next, and 1 from the third part, and nothing from the last, rightmost part. 3 plus 2 plus 1 is 6. That is your number of observations you are drawing from the given fx. So I have calculations, that is probability x1 equal to 3, x2 equal to 2, x3 equal to 1, x4 equal to 0. Put the values in the multinomial formula. Small n is 6, 6 factorial, x1 factorial multiply x2 factorial multiply x3 factorial multiply x4 factorial. x4 is 0, 0 factorial is 1. P1 raised to x1, P2 raised to x2, P3 raised to x3, P4 raised to x4 is 0. Simplify, the answer will come this much. So this is the way of solving the questions related with normal distribution, negative binomial distribution, and multinomial distribution.